This problem looks impossible, ladies and gentlemen. We're supposed to find the last digit of this entire expression. And they would lead you to believe you would have an infinite number of last digits to find, if it behaves like most functions. But notice that the numerator alone is a complex number. Let me write it like this. I'm just circling the numerator. It is a complex number when n is not equal to plus or minus 19. Okay, now that's a very helpful observation because you can't talk about the last digit of a complex number, right? So if n is not, for example, if n were 20, this piece right here would be imaginary. This would be 361 minus 20 squared, which would be minus 39, which is an imaginary number, right? So you see, the only time this wouldn't be, and it would be equal to 0, by the way, if it's equal to either of these numbers, right? So that helps us out a lot in terms of solving this problem. Another important thing to notice is the domain of this function. The only acceptable input is n equals to negative 19. Let's write that down. And it doesn't take long to reach that conclusion. If n is equal to 19, you would have the square root of 38 down here and then 0 here, right? So at least it's defined, okay? But that is the only place it's defined for real numbers, right? N equals 19, that is negative 19, that is the domain. Notice if n were 19, this would be 0 down here, so you'd have 0 over 0, right? So this is literally the only value we really have to worry about, right? And so what happens here, if you're trying to find the last integer of this, we know that this would be 0. This piece right here would become just this part right underneath here. This would be 0. Again, if you put minus 19 in here, just the numerator's 0. And then again, minus 19 is the only value in the domain of the expression, right? Now, so right here you would have plus. What happens when you add negative 19 to 32? What is that, 13, folks? Okay, do we get, 19, that would be 13 raised to the 103. Okay, and again, remember, we're trying to find the last digit. Now, last digits, folks, you have to consider the numbers mod 10. Remember, like, say, for example, 49. It has a last digit of 10, but it's also congruent to 9 mod 10. So we have to consider 13. Let's just take a look, for example, at 13 squared. Okay. 13 squared is equal to 169, right? But this is congruent to 9. Let me write this out so it'll be clear what I'm doing. Mod 10. Modulo 10 is equivalent to finding the last digit. Okay. All right. And then also you can see very quickly here that 13 to the 4th, okay, is going to be congruent to, if you square this side, if you square this side, you get 81, right? Which is congruent to 1, and that's very good news. It's called the order of this element, folks. It's congruent to 1. And again, we're talking mod 10, right? Okay? So what we have right here, folks, is we can rewrite this as this is equal to 13 to the 4th raised to the 25th. This is the laws of exponents. Now, why are we doing this, folks? We know that 13 to the 4th is the same as 1, right, in mod 10. But we still have, what do we have here, 13 cubed left? Okay, 13 cubed left. But notice that this would be equal to, this would be congruent to, and y'all, this again, this whole part is 1, right? 13 to the 4th is congruent to 1 mod 10. So just for instance, I'll write down 1.13 squared times 13. Now, y'all, I wrote it like this because we already know that 13 squared is congruent to 9. So this would be congruent to what, 117? Right, folks? Okay, this part here is congruent to 9. 9 times 13 is 117, but this is certainly congruent to 7 modulo 10. So there you have it, folks. I thought it a very cool problem. It's kind of a misleading problem in a sense. You look at that, and most of us would look at it and go, wait a minute, we have a lot of digits, last digits to compute here. But since our domain consists of one number, 7 is the only answer to this problem, folks. So the last digit is definitely 7. And again, I think a very challenging problem, one I wouldn't figure out. I saw this in a competition type setting once and didn't have a clue on how to solve it, Didn't have a clue because I didn't stop and think, well, you got to find the domain, But you should be suspicious if you see something like this, right? This limits the numerator to just being equal to 0 if you're for any real number that would make sense outside of the complex numbers, right? So the last digit is 7. Let me know what you thought about that problem. It is a competition problem. I can't remember. I think it may be an SMO type of junior or senior problem. But anyway, that does it. Thank you for viewing.